Hello, my name is Zachary Locke, and with my group members Matt Volmar, Stephen Wall, and Logan Emmel, we'll be discussing web scraping in Python. More specifically, we'll be talking about two Python packages that can be used for web scraping, specifically web scraping involving COVID-19 data. We'll discuss the package architecture as well as some practical use for it. So getting started, a brief overview of web scraping. Web scraping, in simplistic terms, is collecting data from websites. What happens is you have some sort of function that receives the data, the HTML data from the website, pulls it into Python, and then is manipulated, optimized, and then stored so that it can be visualized, or it can be used for other purposes. There's a ton of web scraping packages that we can use. The two I'm going to be talking about are URL library, which is the built-in Python library for URL connections, and Beautiful Soup, a web scraping package that I found. So the first one is Python URL library. It is a Python 3 package that can be used to store URLs and pull HTML data from those URLs. It's a 4-part package. It has a request library that is used to open and read HTML. It has an error library that's used for error handling. It has the parse for HTML parsing and the robot parser that's used to parse the robots.txt folder or file that's generated by HTML pages. The library that we're going to be talking about is the URL library.request. Specifically, the main method in that URL library.request.URL open. The one required parameter is the URL that you're opening. And when you run that method, what it'll do is it will attempt to make a connection to the URL you specify, and it will return an HTTP client .http response, which will either be an HTML error code or it will be the HTML data from the page. That object can be cast to a string to get the HTML data if it's a successful connection, and it'll raise some of the URL library errors on a protocol error. The way the data flow for data scraping with this library, the first thing you'll do is run that method to get the HTML data from the site that you're trying to get stuff from. Then you can use regular expressions to clean the HTML data and remove all of the unnecessary things that you don't need, the HTML tags, information not relevant to what you're looking into, all of that kind of stuff can be removed. Then you can use a for loop and iterate through what you do have and store it to a Python map or for each value. Then from that map, you can generate a pandas data frame, and just like we've been doing for most of the semester, you can use matplot library to visualize that data from that pandas data frame. So I'm going to demonstrate what that looks like now. So here in the first section, you can see I import the library, I try to open the page, and on a successful run, I return this HTTP client .http response, which means that my page received some sort of data. Now at this point, we don't know if that data is valuable or not. We'll have to see from future reading. So the first thing that we do is we pull in the bytes, and then we decode it using UTF-8, which is the HTML data encoding, and then we print that as a string. And here you can see the string of all of the HTML data we received. This right here is all of that CSS. Here's some more CSS. There's a lot of CSS on this page. And then if we get way down here, we start to get into some, lots more CSS. Eventually we hit some HTML code. You can see some span classes there, some table data, and some of that kind of stuff. But as you can see, there's a lot of code, and it's not chunked off. It's just very blocky and kind of hard to read. So after receiving this, what we're going to do is we're going to we're going to split based on the table class. Now, there's only one table on this page, so what we can do is we can we can split it and pull that table There's actually two tables on this page. The first one is when we don't need, the second one has information we do need, so we're going to pull the second one using this index value. Then we're going to keep splitting it more and more, trying to remove some of these extra things we don't need, the table head values, and then this splits it on each individual table cell. So now trim is an array of strings, and each array stores a lot of HTML tags and text, and then also stores the data that we need. So what we're going to do is we're going to create an empty map that stores dates and cases. We're going to remove the zeroth term, which is just some headers that we don't need, and then we're going to iterate through the remaining stuff. And as you can see here, we use regex, and this regex, what this does is it removes everything following a span tag, whether that's a span tag with or without the closing symbol. And then what we do is after we remove that, all that we're left with is the data for that cell. And we know that every fifth data cell is going to have a date, and then every fifth plus one cell is going to have a case. So we're going to store dates and cases like that. We'll increase our iterator every time, and then we're going to reverse the data because we want it from old to new instead of from new to old. As you can see, when this runs successfully, this doesn't return anything, but the fact that it doesn't raise any errors shows that it is working. Now we can see what we'll end up having is this data with the cases and the data with the date. What we're going to do is we're going to create a data frame from a dictionary, which is the Python name for a map, and we will now have a data frame that stores our dates along with the amount of cases we had on each of those dates. This is cumulative case count. Now what we're going to use is we're going to use the matplot library to plot this data on a line graph so we can kind of see what the curve looks like. And what this shows us is from March 2020 to March 2021, the amount of cases we had in Missouri in total. You can see there's a couple bumps. There's one there, and a couple up here. But for the most part, this follows a pretty smooth S-curve, and it appears to be reaching a sort of asymptote at around 500,000, which is a good sign in terms of nearing the end of COVID cases. But yeah, this is the plot of that URL plot library's data. Going back to a presentation, the other library I want to talk about is the beautiful soup library. It's a Python package that's based around the soup object. A soup object is an enhanced HTML object that, in addition to storing regular data, stores a parse tree of that data, which allows us to better look through the tree and pull out any specific data that we want. It uses a lot of useful functions. You can use it to index, extract, or modify by the HTML tag that's being referenced, by the text in the HTML page, or by any of like the HTML DOM values. So it's really useful for parsing HTML files. And what we'll end up doing is creating a soup object, modifying that soup object by the tags. This are similar to the way we did it previously using our regular expressions. Then we'll store that data in a map, generate the Panda data frame, and use Matplot library to visualize it. So the process is pretty similar to what we were doing with the URL library, but here you'll see it's a lot cleaner and it gets complete a lot faster. So I'll go over and demonstrate that now. So here we import our libraries again. And this right here creates our soup object. So I'll kind of show you what that soup object looks like. As you can see, it's just the HTML for the page. It doesn't show nearly as much blocky, chunky information as what we got up here. It's kind of pretty and by line, so it's a lot easier and pleasing to read. Now, what we end up doing is we search for all our table bodies in this text, which again, there's only one table in this text. So from that, what we can do is we can clean up the text using regular expressions. We first remove table bodies, then table rows, /n values, the closing tags for cells, and then also remove everything past Missouri because this table features a Missouri, a total for Missouri, and I don't want that for my data. So I'm going to remove Missouri and then everything past it. And what that'll leave me with is this var value, which has all of the text cleaned up a little bit. We'll reinstantiate a Python dictionary, reset our iterator, and very similar to the way we did it previously, um, we will loop through this data or this um, data set. uh, this right here catches to the first row because again the first row is just a blank row, but every row after that, the first term we can add that to the list of regions, the second term to the list of vaccines that we have, and then the fourth row is the population for that region. And what that'll end up giving us is this map that has the regions listed, the vaccines, and the population. The data that I wanted to see is the percentage of people vaccinated per region. So what I ended up doing is um, putting a bar plot down where the x-axis is the regions and the y-axis is the vaccines divided by the population times 100. And then I added some colors to make the graph a little bit more visually appealing. And then I put a title on it, and here's what that graph looks like. And as you can see, it looks like the B region is over 50% vaccinated, and this G region is about 30% vaccinated. And these are the regions that were established by Missouri in response to COVID. So anyway, that's our libraries that we decided to talk about for web scraping. Thank you so much for listening.